Hello, Honors Algebra students. Mr. Lawrence here, and of course, who else would it be? Going to go through the questions from the quiz from Thursday afternoon. You've already worked on your corrections, but I want to draw attention to how I would have solved these and point a few things out, and hopefully that will help you work with your clusters, okay? The 5 or 6 of you who ace the quiz, you don't need to be watching this. You certainly are welcome to, but if you want to take the night off from the video, you go right ahead. All right, everybody else, please pay attention. All right, problem number 1. With a problem like this, I need to listen to Saddam. I'm going to undo a subtraction and addition before I undo division and multiplication. Now, some of you want to multiply to get rid of this 2 first. You can do that, but you have to multiply all 3 terms by 2, and most of you won't do that. You're just multiplying here or here and here. No, you have to distribute on the left-hand side. I don't do it that way. It's not wrong to do it that way, but you have to make sure you multiply 2 times 5 is 10, and then here the 2's will cancel, but a lot of you are going to make so many mistakes. I'm not going to demonstrate it that way. But that's the mistake some of you are making, is that you're only multiplying this term by 2. Anytime you multiply or divide through an equation, you're going to have to do it to every single term you see. That's why it's smart in some cases to simplify, combine like terms before you do any multiplication. But I'm going to listen to Saddam, and I'm going to get rid of this 5. It's a positive 5, so I'm going to subtract 5 from both sides, and then I'm going to get negative x over 2, and that's going to equal 2. Now I'm ready to go ahead and multiply, and remember, we don't do times 2 down here in the denominator. We write like that, negative 2 over 1, and we're going to multiply by negative 2. All right, here the 2's will cancel. The negatives will cancel. We'll be left with x on the left-hand side, and the right-hand side is negative 4. Now, as a solution set, of course, it looks like this, right? Okay, number 2. Now, this is one where you can multiply first. We don't want the 2 fractions here. Now, if I multiply this one by a 5, that would get rid of that denominator, but that would not get rid of this denominator. I need a number that will get rid of both denominators in one shot. So I'm going to find the least common multiple of 5 and 4. Remember, you can count by 5s, 5, 10, 15, 20. Stop! Because 4 goes into 20. I'm going to use 20. Right? Going to use 20. Now, if you don't want to think about it as 20, you can think about it like this. You can think about it as 5 times 4 over 1, and over here 5 times 4 over 1, and here I'll do just a plain old 20. Why might I do that? Well, here it might be easier to see that the 5's are going to cancel. 4 times x, 4x. Here the 4's are going to cancel. X times 5, well, that's 5x. 2 times 20 is 40. Now I'm going to combine like terms and get a negative x. That'll equal 40. I remember that this is a negative 1x, so I can divide by negative 1 on both sides, and then x will equal negative 40. And there you go. Of course, the solution set is negative 40. Yeah, even I have trouble sometimes. I've been doing these for years and still make a screwy one every now and then. All right, number 3, I can also multiply first. I cannot add 1. I cannot do this. No way. That's not a 1. That's a 1/3. Now, some of you might want to write it as 2 separate problems. 7x over 3 minus 1/3 equals 5. And then treat it like the last problem, multiply through to get rid of the denominators. And that's a great way to do it. I'm not going to rewrite it. I'm just going to go ahead and multiply by the denominator, by the least common multiple. There's only one denominator, and so it's just multiplying by 3 in this case. The 3's cancel. Nothing left to distribute here. This becomes 7x minus 1. Right-hand side, we get a 15. All right, we're going to add 1 to each side. It's just a 2-step equation from now on. 7x is going to equal 16. Going to divide by 7. Going to divide by 7. X is going to equal 2 and 2/7. If you have trouble converting that, please let me know. It's such a simple thing. I can help you. All right, so we're going to get a 2 and 2/7. All right. Excuse me. Coming down here to problem number 4. excuse me, a lot of you like to get rid of these numbers first. I don't. I dislike this problem because there's x's on both sides of the equation. I'm going to get rid of the 5x first. It's not wrong to do it the other way, but some of you miss the punchline when you do that. So these are going to cancel, these are going to cancel, and I'm going to get negative 6 equals negative 6. When does negative 6 equal negative 6? It always equals negative 6. They're always equal to each other. That means the solution set for this is all real numbers. Okay, if you want to write that out, you could say x is any real number. Okay, any real number. All right, if I had come up with a false statement like negative 6 equals negative 8, that's never true, then it would have been no solution. But this one is all real numbers. If you don't believe me, pick any number you want for x, plug it in here, and also over here, and simplify both sides of the equation. You will get the same number. All right, this one here, I could distribute first, or since 15 can be thought about as 5 times 3, I might want to go ahead and divide by 3 on both sides to make things simpler. So I get 2x minus 5, and that's going to equal 5. Yeah, that is a 5 there. There we go. I'm going to add 5 to both sides. And I'm going to get 2x equals 10. I'm going to divide by 2. X is going to equal 5. Solution set is 5. All right. Now, number 6. It's an inequality. So, it's a two-step inequality. I'm going to start off by listening to Saddam, subtracting 6 from both sides. And I'm going to get negative 2x is less than 9. Now, you have to be careful here. Most of you know you're going to divide by negative 2. But remember, when you multiply or divide by a negative, say this with me, when you multiply or divide by a negative, the inequality flips. The inequality changes direction. The alligator turns around. The alligator turns around. Pac-Man goes the other way. Cookie Monster turns around. However you want to remember it. There's my sentence. My solution set now is x is any real number such that x is greater than negative 4.5. All right, and then the number line, let's see here, I'm going to need a negative 5, a negative 4, a negative 4.5. We're going to have an open circle, an open point, excuse me, we need numbers bigger than negative 4.5. Please start testing. Please don't just guess. Put a number bigger than negative 4.5. How about 0? 0 is definitely bigger than negative 4.5. I'm going to shade towards 0. And there it is. Okay, number 7, last problem from the quiz. I've got x's on both sides. I'm going to take away the 12x. Take away the 12x. I know some of you are saying, Mr. Lawrence, didn't you always say to... Yeah, I did always say to take away the smaller coefficient first. It'll make things easier. I'm doing it this way on purpose. You'll see why in a minute. Plus 12 greater than or equal to negative 5. And then I'm going to subtract 12 from both sides. Not 21, Mr. Lawrence. What are you doing? Sorry, it's getting kind of late. I'm very sleepy. I've been working too much today. By the way, I love the girls' volleyball game. Great job, Maggie, and all your other teammates. Megan and Laura and... I'm thinking that's all the people in honors. I hope I didn't... Oh, Laney. Sorry, Laney. Didn't mean to forget you there. I really love the game. I was thinking also my other students who are in it. Madeline and Aaron. But anyway, girls, you looked really good out there. I'm proud of you. You did a nice job. My kids love the game. So thanks for the entertainment. Good work. All right, back to the problem here. Now I'm going to divide by negative 2. Remember, when I multiply or divide by negative 2, the inequality turns around, and I get 8.5. Okay, the solution set would be x is any real number such that x is less than or equal to 8.5. And then my number line looks like this. I'm going to show 8, I'm going to show 8.5, I'm going to show 9, it's going to be a closed point. Now, some of you don't know which way to shade. Take the x out, leave a blank there, fill in the blank. Give me a number that is less than or equal to 8.5. Don't use 8.5. How about 8? I'll shade towards the 8. There you go, got a true statement. Now, one thing I want to make mention of, some of you have a very bad habit of going like this. You know, you have 10 is greater than or equal to 2x, and then you divide by 2, and then all of a sudden you go x is greater than 5. No, 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 you can't do that. You can't do that. Don't change the problem. Look, keep things lined up and organized. This is 10 divided by 2, so it's 5. There's the inequality. It doesn't change direction because I didn't multiply or divide by a negative. And these, the 2's cancel, and I'm left with x. This is not the same as this. They are not the same expression or inequality. So don't change your order. Keep things lined up. All right, that's it for the video. On Friday, you ladies and gentlemen will be taking your actual quiz. All right, Mr. Lawrence signing off. Good night, everybody.